Alright, it's time to get into some more of the technical discussion about how encryption actually works. Now once again, don't worry, you don't have to be a mathematical genius to understand encryption or to make it work every day in your life. However, it's a good idea to understand some of the mechanics of how it works because that will help you to better select encryption technologies, methods, and so forth that you will want to use to protect your data. So there's a few other terms we're going to talk about, algorithms and keys and so forth. First, let's talk about algorithms. Now there are two parts of encryption that are very important. There's two major elements. There's an algorithm and a key. Those two things are what encrypts and decrypts data. Now the first part of this is algorithms. Encryption algorithms are basically mathematical formulas or methods that we use to encrypt or decrypt data. Okay, there are several algorithms out there, several popular algorithms. There's RSA, there's two-fish, there's DES or DES, there's triple DES, there's AES. There's a whole slew of algorithms out there, and each have their strengths and weaknesses, and each can encrypt data in different ways, and we'll discuss some of that more as we go. Now this algorithm, again, a mathematical formula or a method for encrypting and decrypting data. Okay. We use that in conjunction with the key. Now the key is usually kept a secret. Normally no one knows the key. But the algorithm is usually public or known. As a matter of fact, we want the algorithms to be public or known so that we can vet them or see how strong they are and look for weaknesses. Okay? So the algorithm is usually public. That's not a real big secret. The key is what is secret. Let me give you an example, a very simple example of algorithms. The algorithm may be, for example, in a substitution cipher, okay? Move the plaintext letter P a certain number of spaces to the right, and that certain number of spaces represented by X would be the key to get whatever ciphertext called C that you're trying to get. This is a very simple substitution algorithm, and we'll demonstrate it as we go through the course. Now this algorithm may be well known. Your enemies may know that you're going to move a certain plaintext letter X number of spaces to the right to get a certain other character. But they don't know how many spaces to the right. That's X. That's the key. That's what you keep secret, so nobody can use the algorithm to break the code. For example, here is a very simple substitution cipher called ROT13, and it's actually a Caesar cipher. And we probably use this in maybe grade school, okay, if you want to pass secret messages on the playground. Now what you have here is a substitution where A is N, B is O, C is P, and so forth. And that's called a ROT13 because A has moved 13 spaces to the right to the letter N. Okay, 13 is the key. Now you could do this any number of spaces. You could say move the letter 3 spaces to the right. So A would then be D, okay, not including A. So it would be B, C, D, you would move it to the right, and so A would be D, B would be E, C would be F, and so forth. In any case, you could do that with any number of spaces, and that would be your key. So as you can see, using this method, the word hello becomes URYYB. Very simple. This is a very simple, again, substitution cipher. This is a very simplistic example. Now, of course, we don't use these simple examples in modern cryptography. The algorithms that we use today are much more complex. They use a wide variety of mathematical functions. Some use very large prime numbers. Some use logarithmic functions. Some use even more complex mathematical functions. But again, the thing about this is you don't have to be a mathematician to understand encryption or to make it work. What it would be helpful is if you understood some of the different kinds of algorithms out there, what their strengths and weaknesses are, and we'll go through that as well as we go through the course. But you don't really have to know the mathematics of it. If you are an IT security professional, you're likely going to learn some of those more complex methods of encryption and how they actually work, such as how many rounds a particular encryption algorithm uses, whether it's a block or a stream cipher and so forth. But if you're a normal user who just uses it to encrypt email or encrypt a file on your hard drive, you don't have to know that. The next thing we'll talk about in a moment is keys, and that's the second half of this particular mechanics of how encryption works.